Okay, so this one, you're given the graph of f has a derivative, so that I guess this is f up here. I'm going to pretend it's f. The portion of the graph of f is shown above, so there's f up there. Tangent line at x equals 2. Let g be this function over here. So again, like the previous problem, we're going to have to make a Taylor polynomial for g. It's only a second degree, and we're at x equals 2. So g of x, I'll write it over here just so you can see it. G of x is equal to 3 plus 2x f of t dt. So g of 2 is going to be 3 plus 2 to 2 f of t dt. Integral at a point is just equal to 0, so we just have g of 2 is equal to 3. G prime of x, derivative of a constant goes away. Second fundamental theorem of calculus, slide the x in, take the derivative of what you're putting in. Derivative of x is just 1, the 2 goes away. So we're just left with f of x. G prime of 2 is equal to f of 2. I look at my graph up here, it says f of 2 is equal to 1. And I went to second degree, so I need to take another derivative. So g prime prime of x is f prime of x. Might be hard for you to see, but there's a point right there at 1 comma negative 2. There's that point right there, which is 2 comma 1. So I just need to find what is the derivative at that point, and I'm just going to use the idea of slope or rise over run. 1, 2, up 3 over 1, so therefore this is going to be equal to 3. So my second degree polynomial is going to be 3 plus my first derivative, which is 1 centered at 2, which is x minus 2. My second derivative is 3. So this is plus 3 over 2 factorial x minus 2 squared. So I'll just rewrite this as 3 plus x minus 1 plus 3 halves x minus 2 squared. Okay, I'm running out of room here, so I'm trying to squeeze things in. They want to know, is there a min or max or neither at x equals 2? So we just need to know what is g prime of 1, what is the first derivative? Well, g prime of 1 is going to come from this term right here, and hopefully we're all okay that the derivative is just going to be equal to 1 because of, we already did it right here, g prime of 2 is equal to 1, but if you want to check, we can do the first derivative of t is just, this is going to go to 0, that's just going to be 1. This is going to be plus 3x minus 2. If I do t prime of 2 at 2, this is 1, this guy goes away because it's 0, I have 1. Using that same logic, the second derivative for g at 2, this should have been g prime prime of 2 is equal to f prime of 2, which is equal to 3. So just minor notation there. Again, g prime prime of 2 is equal to 3. We just did that, right? We did that for this part up here, but if you want to write it out just to verify, t double prime is just going to be 3. Right? And so therefore t prime prime of 2 is equal to 3, and so therefore do I have a min or max? I do not, because my first derivative is not equal to 0. So there's no min or max since g prime of 2 is equal to 1, which is not equal to 0.